Look at these videos. They show different types of chemical reactions. Let's learn more about the types of chemical reactions. There are many different types of chemical reactions. Chemical reactions can be grouped according to their reactants and products. The types of chemical reactions we're going to talk about are synthesis, decomposition, single replacement reaction, double replacement reaction, combustion, and acid-base reactions. In a synthesis reaction, two or more substances combine to form a single compound. Here's an example of an equation of a synthesis reaction. In this equation, solid magnesium combines with oxygen gas to form solid magnesium oxide. This shows the reaction taking place. You can see that it's an exothermic reaction because light and heat are given off. The two reactants form one product in this type of reaction. Another example of a synthesis reaction is the combination of sodium and chlorine to form sodium chloride, which is table salt. Two reactants form one product. You can see in this video that the reaction is exothermic, produces light and heat, and we're going to use a cartoon analogy to help us remember the different types of chemical reactions. For synthesis, we want a cartoon that shows two elements coming together to form something new. And so what we have here are two friends at a school dance joining together to be a couple dancing together. That's why synthesis reactions are sometimes called combination reaction. Let's review. A synthesis reaction is one in which two reactants form one new product. The next type of reaction is called a decomposition reaction. It's a reaction in which a single compound breaks down to form two or more simpler substances. An example is the decomposition of water, which can be done through electrolysis. Water molecules can actually be broken apart and form two gases, hydrogen gas and oxygen gas. This video shows how it can be done.
I'm going to show you electrolysis of water setup. So we have a mini Hoffman apparatus, and I'm going to take this little test tube here, and I'm going to dip it under and fill it completely with a 3 molar sodium hydroxide solution. So since we're starting with that completely filled up with solution all the way to the top here, it's going to allow us to collect gases in each of those. So we're going to run a red lead to the negative terminal of the battery, a black lead to the positive terminal. And when we do that, you can see bubbles starting to originate in there. I'm going to zoom in so we can see that up close. And that gas is collecting on the left and on the right. So we're going to let that run until we've collected enough to make a measurement. About 3.7, 3.8 milliliters for the smaller of the two. And the larger of the two is currently at about 7.6, maybe 7.7. Okay, so 3.8, 7.6, looks like we have twice as much gas on the one side than the other. Let's hook these back up. So this has now been filled all the way. And we're going to take this one is the one that is completely filled up, and there's our successful hydrogen test. Okay, and the other one, so we're going to do a second test with that. We're going to do the oxygen test. So we're going to grab this, put it upside down, and you can see that it easily ignites back into on fire, confirming the presence of oxygen. So we have our flint out, and we have our flint back on fire. So again, we're seeing a 2-to-1 ratio of hydrogen gas to oxygen gas, and confirmation of what the two gases are.
So you can see in the video that the coefficients in our equation that we take water and come up with 2-to-1 hydrogen to oxygen is very easily seen in these test tubes where we had twice as much hydrogen and half as much oxygen, 2-to-1. Another example of a decomposition reaction is when we have carbonic acid breaking apart or decomposing to form water and carbon dioxide. And that's a reaction that happens in our soda when the carbonic acid becomes carbon dioxide and water, and we get those nice fizzy bubbles. Our cartoon analogy for this would be as if we had friends who were dancing at the dance, and so they were a couple together, but then they break apart to stop dancing, and now they're two individuals. So this breaking apart into two new things, starting with one couple and becoming two separate individuals. To review, in a decomposition reaction, we have a compound that breaks apart to form two new compounds, or a compound in an element. One reactant forms two products.